Right now, you feel completely still. Maybe you're sitting on a couch. Maybe you're lying in bed. But nothing about your body is telling you that you're moving. You're wrong. Earth is spinning you around its axis at over 1,000 miles per hour. At the same time, the planet is flying around the sun at 67,000 miles per hour. The sun is dragging the entire solar system around the galaxy at over 500,000 miles per hour. And the galaxy itself is moving even faster than that, through space, toward a destination we can't fully explain. Add it all up, and you are moving at more than 1,000,000 miles per hour right now. And you can't feel a single mile of it. Here's the actual math behind that. And here's why your body has no idea. Start with the simplest motion, the one under your feet. Earth rotates once every 24 hours. If you're standing near the equator, that means you're being carried around the planet's axis at roughly 1,037 miles per hour. That's faster than the cruising speed of a commercial jet. But the number isn't constant everywhere. Move toward the poles, and that speed drops fast because you're closer to the axis Earth is spinning around. Stand exactly at the North or South Pole, and your rotational speed is basically zero. You just turn in place once a day, like the tip of a clock hand. So why don't people at the equator feel like they're on a 1,000 mile per hour carousel? Because speed alone isn't what your body detects. Change in speed is. As long as that rotation stays constant, there's no jolt, no push, nothing for your inner ear to register. The atmosphere, the ocean, everything around you is spinning at the same rate. So relative to your surroundings, you're not moving at all. This is the first clue to something that's going to keep showing up for the rest of this video. Motion without acceleration is invisible. Zoom out past the spin, and Earth is also making a much bigger loop, an orbit around the sun that covers about 584 million miles every year. Divide that out, and Earth is moving through space at roughly 67,000 miles per hour, almost 19 miles every single second. To put that in perspective, the fastest fighter jets top out around 1,500 miles per hour. You'd need over 40 of the fastest aircraft ever built lined up end to end just to match the speed you're already traveling at right now, without doing anything. This orbital speed isn't arbitrary either. It's a balance. Gravity from the sun is constantly pulling Earth inward, and Earth's forward momentum is constantly trying to fling it outward in a straight line. The orbit is what happens when those two forces cancel out perfectly, an endless free fall around the sun that never actually lands. Change the speed, and the orbit changes with it. Slow down, and Earth spirals inward. Speed up, and it spirals away. The 67,000 mile per hour number isn't random. It's the exact speed required to keep us exactly where we are. Here's where most people's mental model runs out, because we tend to picture the sun as the fixed center, with everything else looping around it. It isn't fixed at all. The sun, along with the entire solar system, is in orbit around the center of the Milky Way, and it's moving at around 514,000 miles per hour to do it. Even at that speed, one full lap around the galaxy takes about 230 million years, a length of time astronomers actually call a galactic year. The last time the sun was in this exact position in its galactic orbit, dinosaurs hadn't appeared on Earth yet. Complex land life was still figuring itself out. We are currently on the same galactic orbit that started before most of the history of life on this planet. And we won't complete it again until long after humans are gone, one way or another. That's the scale we're dealing with once you zoom out past the solar system.
You'd think the pattern would stop somewhere. It doesn't.
The entire Milky Way, along with the rest of our local group of galaxies, is moving through space at around 1.3 million miles per hour. And this motion isn't measured against some fixed backdrop. It's measured against the cosmic microwave background, the leftover glow from the early universe that fills all of space evenly. That glow is the closest thing scientists have to a universal reference point. When astronomers measured it carefully, they found it looked slightly warmer in one direction and slightly cooler in the opposite direction. That temperature skew is a direct signature of our motion. We're getting compressed light waves from the direction we're heading and stretched light waves from the direction we're leaving. And that direction points toward the same region covered in the Great Attractor video, a gravitational anomaly hidden behind the dense core of our own galaxy that we still can't directly observe. So this isn't a separate topic, it's the mechanism behind it. The Great Attractor isn't just an interesting anomaly sitting out there. It's the reason our entire galaxy has a direction and a speed at all. Here's the part almost nobody covers. You'd assume you could just add all these speeds together. Spin plus orbit plus galactic motion plus local group motion, and get one final number for how fast you're really moving. It's not that simple, because these motions aren't happening in the same direction. Earth's spin, its orbit around the sun's path around the galaxy, and the galaxy's drift through space are all pointed different ways at different times. Depending on the season, Earth's orbital motion around the sun is sometimes lined up with the solar system's galactic motion, and sometimes working against it. That means your actual total speed through space isn't fixed. It shifts throughout the year as these vectors align and cancel by different amounts. So the honest answer to how fast you're moving isn't one number. It's a number that changes depending on the day, the season, and which direction you're facing on the planet at that exact moment. This all circles back to the same principle from the very first point. Your body doesn't have a sensor for speed. It only has a sensor for change in speed, acceleration. Every motion we've covered, the spin, the orbit, the galactic drift, is happening at a constant rate. No sudden pushes, no jolts. This is the same reason you can't feel the motion of a plane once it's cruising at altitude. Close the window shade and pour a drink. Nothing spills, nothing tells you that you're crossing the country at 500 miles per hour. The moment the plane hits turbulence, that's acceleration, and suddenly you feel every bit of it. Einstein built an entire framework around this idea. There is no experiment you can run inside a closed room that can tell you whether you're sitting still or moving at a constant velocity. Physically, those two states are indistinguishable, which means the question of how fast you're really moving doesn't have a single true answer. It depends entirely on what you're comparing yourself to.
So next time it feels like you're sitting completely still, you're not. You're spinning, orbiting, and drifting through space at well over 1 million miles per hour combined. And there's no version of stationary that actually exists anywhere in the universe to compare yourself against. Every point of reference is moving relative to something else. Standing still was never actually on the table.